Afternoon. I'm Dr. G. Vijay Kumar, the Professor, Department of Agriculture Engineering, Sri Shanmuga College of Engineering and Technology. So today, let's have the topic of drip irrigation system. So drip irrigation system is defined as the irrigation water is supplied to the plant by drop. That is what micro irrigation. Under micro irrigation, it is what working. So let's have the system. Application of water in small quantity at the rate of less than 12 lph a liter per hour as drops exactly at the root zone of the plants through a network of plastic pipes fitted with the emitters. So at the end of the lateral we are fixing the emitters. That emitter is discharging the water as drop by drop exactly at the root zone with 12 maximum of 12 liter per hour discharge rate. Operating pressure for this drip irrigation system is 200 to 20 to 200 kilopascal or 1 to 2 ksc, that means kg per centimeter square pressure. The discharge varies from 0.5 to 12 lph depending on the soil type discharge. So the top soil type means the soil is having different various properties, infiltration, percolation and other things. Based on that, the discharge rate is provided as like soil, sandy soil or clay soil. Both the soils are extreme soils. The pore space is very less in this clay soil, so this may require higher discharge rate, and the infiltration layer is very less. The lateral movement is greater than the vertical movement. So according to that, but in other end the soils like sandy soils are having porous soil. Those soils may be the less lateral movement and a greater vertical movement. So according to that we can choose the emitters for the drip irrigation system. So these are all the advantages of drip irrigation system. One is called percolation and evaporation losses are minimized. High application efficiency is achieved. Labor requirement is minimized. Land area required for bunds and ridges is saved. Increases in production and productivity. This is very important advantages. So we can increase the yield of any crop about 3 to 5 times as compared to the conventional method of irrigation. So that also provides the water saving. So this is the prime objective of the drip irrigation system, and also it saves 40 to 70% of water saving, so that we can irrigate 2 or 2.5 times the area irrigated as compared to the normal area by conventional method of irrigation. And additionally, the weed control, saving of fertilizers and labor cost is also reduces as mentioned in 30% and 10% respectively. Then control diseases, use of saline water is also possible. Soil erosion is eliminated. The prime objective of the drip irrigation is one of the prime objective is the soil erosion control. That is also possible, suitable for uneven undulating area. Since we are supplying the irrigation water through the pipe network, it is possible to irrigate or supply the water uneven in the undulated or uneven areas. High water use efficiency, the output divided by input will be greater. So the what is the amount of water is given supplied, that is what input, and from that what is the amount of water is utilized by the plant, so that is the output in terms of yield or total depth of water. So this ratio gives the maximum efficiency, and also we are already it's mentioned that the productivity is increased to 5 times. So definitely the water utilization is also minimized. So the concept is the yield is increased and water utilized is minimized, so automatically this enhances the high water use efficiency. That is possible here. Is there any advantages? There will be disadvantages. So here also some of the disadvantages of drip irrigation system. So initial capital investment is very high. So since it consists of a total length of the lateral is very high. For example, for installing the drip irrigation system for vegetables are having less spaced crop, and other perennial crops are having higher more spacing crops. For the less spacing crops are needed high investment. since the amount of lateral pipes are required more than the more crop spacing. You take the example of vegetable crops installed the drip irrigation for 1 acre, it will cost around 75,000 to 1 lakhs. But in the case of fruit crops like mango, coconut, or something else, amla, pomegranate, for this type of crops the spacing between the crop is very high, so the lateral requirement is very less, so that the 1 acre installation cost may varies about 30 to 35,000 only. So this is the capital cost. Though the initial capital investment cost is very high, but our farmers are marginal and small farmers, then they may not having the amount for investment of this initial cost, so that our government is providing this subsidy also. About 90% subsidy is providing with the government through agriculture engineering department as well as the horticulture department. So the farmers nowadays are familiar with the installation of the drip irrigation system, uh, though initial capital investment is high. Then second one is the high skill is required for design, installation and maintenance of the system. Definitely this system is required, so the slope of the area, though the system can installed even in the undulated area, but the design is required proper guidance for the design, and also the installation maintenance to be properly maintained. The installation is also required the high skilled labor. The maintenance, like such as when even we are using the saline water, though the clogging of emitter will occur, so during that time we have to treat the water by the chlorination, by adding the hydrochloric acid with composition. Then the salt accumulation in the pipes and the laterals will be really removed, so that the maintenance will be taken of it. In clogging of emitters may create a problem. In case of salinity, salt cannot be leached. That is what I mentioned. The uniform distribution of water is difficult unless very careful design. Then uniform distribution of water is not done properly, then uniformity efficiency will be reduces. Actually in the drip irrigation system, the uniformity efficiency may be expected about 90, more than 90%, 95%, but that will affect in this system if we are not maintaining the uniform distribution of water. So this is the drip irrigation system working principle. So the water is available on the water source and it is pumped through the pump. Then it is sent to the top right corner. I am explaining bypass valve. The bypass valve is used for sending the return water. If there is a return water, then to control the return water, we have installed the NRV, non-returning valve, and also the cyclone separator, the hydrocyclone or sand separator is used. Since the water is consist of sand particles, so we have to remove the sand from this water, so that the pure water will be sent to the drip irrigation. Otherwise the sand particles will clog the emitter even. The cyclone separator or sand separator hydrocyclone filter is working under the concept of density difference. Then the water is lesser density than the sand particles, so the sand particles will be underflow due to its higher density, and the water is lesser density, so its overflow and it is taken on the top. Then it is sent to the fertilizer injection devices such as Venturi, and Venturi is working for injecting the fertilizer solution, and both the water and the fertilizers will be applied here. This technology is known as drip irrigation, and it is sent to another tank that is called sand filter for the further filtration process, and secondary filter is also used as a screen filter here, and the screen filter is consist of screens inside the structure, and it's filter the small chemical immobile properties, so that it may not enter into the drip irrigation system. Then NRV again we are fixing a non-return valve, then main line, sub main line, and laterals emitters are fixed here, and it is working under the pressurized irrigation system. Sometimes we are using the air valve to release the air bubbles, otherwise the water hammer may occur. Then submain and the laterals, main lines are consist of, at the end of these pipes will have the flush valves for the flushing of dust particles and others. This is the fertigation system, or I have explained the venturi system. So the bypass venturi is fixed on the bypass so that the fertilizer, the vacuum is created, so the pressure will drop, so that the suction of the fertilizer solution will take place and it is mixed with the main pipelines. So thank you.